So I'm gonna change context slightly because I don't use that interpreter normally either. So this is a slightly more full-featured interpreter that I use in my personal life. It's called IPython and it exists. So if I have an audio file, I can make this available. People want it. That does what we just did, but with a little bit of functionality. And I have another one that does some basic things with audio. So here we're going to do two things. We need to import AudioLab. So SciKits is where the extensions live. So it's SciKits.AudioLab. And I don't like typing. And then we need Numpy. And so what's the easiest thing? So if I want to read in a WAV file, so I have this WAV file that is actually some Mozart. Yeah? Sounds like this. Yeah. It's some opera. And so the way that we read that in is like this. I'm going to cheat. So here is where it lives. So, and that's what do I call it? Catalog. So now you'll notice that what happens here is something that makes more sense based on what we've been talking about for the last week. So when I read the wave in, rather than all this sort of business, you have separation. So you have the audio, the sample rate, that's freak, this is the sample rate, and then the encoding. And the encoding is how the data exists. So in this case, that's PCM, and what the bit depth is. So that's going to say PCM 16 when I read it in. So now audio contains the actual audio data, and we'll get to that in a second. And freak contains 44.1, which is the answer, and encoding contains PCM 16. Yeah. So in this way of sort of thinking about things, the audio is actually a really big matrix. So we've got two channels, so there are two rows, and there's a column for every single frame, right? And it's all just hanging out in memory. Well, it's not really hanging, it's pretending to hang out in memory. And so what AudioLab makes available on Mac and Linux, and in a way that's not reliable Windows, is you can play using the OS's capability to play inside the interpreter without having to drop back into WAV. So a really easy thing that we can do, or nearly easy thing, is we can play the audio, which annoyingly is slightly complicated. So it looks like this, and I'll explain this slightly. So what we're doing is we have the audio, and the play, for reasons that I need to write the author and tell him are silly. So you have a matrix, right? And the matrix is like this, but the play expects the matrix to be like this. So you have to flip it, and that's what this thing right here, swap axis. It's very similar to MatLab. For those who know, you're rotating the matrix, right? So instead of having a 2 by length of song, you have length of song by 2. And I don't know why AudioLab is inconsistent, but it's not. But actually, this isn't what we want to do, because we don't want to listen to the entire 2-minute clip of opera. We're just going to listen to some of it. So how do you?
Thank you.
Yeah, you're welcome. So the way you listen to some of it is, so do you remember how when you have a list, you can specify just one thing in the list, right? Like just 10, right? So that's not right either. That's just one sample. What we actually want is a range, right? So the range, I don't think it's been said explicitly, but
slicing,
okay, but so this colon basically means everything in front of 10. So this would be the first 10 samples, which is not actually very much. So this is 44.1. So a little math in the head, 5 seconds. Remember we did this earlier. This is 22,500, right? It could actually be freak times something, and that would be okay. So if we wanted to make this easier to read, we could actually do this, right? So frequency times 5, that's 5 seconds, right? So this should play the first 5 seconds. I didn't screw something up. Okay. So that audio. So if we go back to that audio. So remember, the audio was a big mess. It was some unintelligible gibberish. So if we go audio, let's look at the first 10 pieces. So here we have audio : 10. those are floats, right? So if you've looked at raw audio data in any other context, these numbers start to make sense, right? So this is a believable piece of audio. So better than that, also in Python, there's a thing called PyLab or MatPlotLib.
We've got about a minute to
Okay, so it exists. It's for plotting. Other than that, we don't quite have time. It has very similar syntax to MATLAB, so some people may recognize this. So if I want to plot the first 5 seconds of this song, it would look like this. Plot, sorry, I have to put it in front. PyLab.plot, just like how I played it. Audio. This is going to complain about something, but we'll talk about that in a second. So if we don't, 5, right? So this is actually is going to yell at me, but we can discuss why in a second. So, oh, it worked. That's exciting. Right, okay, so what it did, it just plotted both channels on top of each other because I didn't do much effort. The colors are slightly more aware. But anyway, this is the first 5 seconds. The blue, which is behind the green because of the way the plotter worked by default, is the left channel, and the green is the right channel. So those are 2 channels of audio in, like 3 lines of Python, right? So if you want to poke in this direction, these are the packages that you should be using, and we'll talk about how to install them later.
Okay, thank you very much.